So in this video, we're going to talk a little bit about the differences between the Lite and the full version of SkySafari. One major difference, of course, is telescope control. The ability to control a telescope is only in the full version. But in addition to that, there's a number of other differences as well. The first difference is just in the amount of data that's included with the program. The Lite version of SkySafari has about 120,000 stars. The full version has 2.5 million. And so as you zoom in, you can really see a lot more of the fainter stars that you could see with a small telescope. In addition to stars, the full version of SkySafari has images of star clusters, nebulas, galaxies built into the program. To get those, you need to purchase the SkySafari expansion pack, and once you've gotten that, you can turn them on by going to your deep sky settings and turning on the images switch. So now, in addition to the outline representation of a galaxy, you also have a real image of the galaxy. In this case, it's M31, the Andromeda galaxy, that you can see in the fall. Almost hundreds of images of many well-known objects. For example, let's pick a Messier object, the Lagoon Nebula here. So here's facts and figures, descriptions. If we center on the object, it's located in the center of the Milky Way in Sagittarius. And this image is a real digitized sky survey image of the Lagoon Nebula. And that's a feature that you also get in the Pro version of SkySafari. You also have more advanced charting features, such as the ability to put a celestial grid on top of the sky. And I'll do that by turning on the grid switch here. And so now you'll notice there are grid lines that indicate the lines of right ascension and declination. Of course, the celestial coordinate system is oriented around the Earth's north celestial pole. There's the star Polaris here, very close to the center of the celestial coordinate system. In SkySafari, in the full version of SkySafari, you can also show the sky without the horizon aligned to the celestial coordinate system. So what I'll do is I'll go to our celestial coordinate setting, use equatorial as the celestial coordinate mode, and now as I zoom in and out, I've got a sky that's fully aligned to the celestial coordinate system without a horizon to block the view here. And this is really useful for showing phenomena such as the motion of the planets, which take place against the background stars, but don't have a time scale on the order of the Earth's rotation. In other words, they happen showing the motion of the planets over the course of days or months, rather than just the diurnal motion of the stars that happens over a course of minutes. For example, let's set the time here to 1 day per step and run the time forward. And so now what you're seeing is the motion of the planets as the Earth is moving around the sun. So we're looking at Jupiter in June of 2009, and let's zoom in on the planet here. And so as we zoom in, you can see the moons of Jupiter appear. They're all drawn correctly according to their correct position and scale at the time. And as we bring up our time flow controls here, we'll animate the motion of those moons. And what you can see is not only do the moons move, but the moons cast shadows. And this is actually a somewhat rare double shadow transit of Jupiter's moon Io and Ganymede, both casting shadows on the planet. This is an example of the precision that's built into SkySafari. No other iPhone app can display this kind of phenomenon accurately. And that's why we think it's a great deal both for beginners and professionals and amateur astronomers alike.